everyone behave now. Okay, let's go. So this is our guide to Angular. It is being recorded. It's mainly targeted at juniors, and we should hopefully be doing a series moving up through all the different pieces, and hopefully not too long before we get into some more advanced and interesting topics.
Uh-oh.
Uh-oh. Okay, work out how to change slide. So today what we're going to cover is the Angular CLI, have a look at components from a real basic level, and touch on modules as well. So the Angular CLI is quite an interesting one. Definitely a personal lesson from me here is Angular has quite a lot of scaffolding, which I think sort of to help make it optimized and build correctly. And trying not to use the CLI. Generally, I'm more of a fan of lighter tooling, but trying not to use the CLI and the tooling for things like VS Code just makes your life hell with Angular. So definitely these things are really good and save you a lot of time. The CLI will help you build a lot of components and stuff like that. The only thing it really doesn't help with is moving pieces around.
Okay, cool. So starting off with like generating components, one of the smallest structures. This is kind of my workflow. So when I'm in VS Code, I basically open the folder that I want to be in terminal. So ngg is kind of short for ngGenerate. And just type in your component, name your component, and then there's a bunch of options. I recommend reading up on those because there's some stuff that might sort of suit your needs. So this is great because when you're creating a component manually, it can kind of be quite a lot of scaffolding, like Rob says. So what this will do is it will create all the files necessary, and it will also declare it in the nearest module. So kind of everything you need to do to generate and register a new component, it will do it all for you. So when you're creating, 10, 15 components for a story, this will save you quite a bit of time. Next slide as well.
Would you say, like, generally, like I'm making a new feature, you'd generate the module, and then you generate the component services, things like that after, and it ties all that together?
Yeah, if I was creating like a new feature module, create a module, and then in my components folder, I'll kind of preemptively create everything I need. So I'll do, ng generate component, data list, ng component, data view, data edit, that sort of thing. So you're kind of generating them all up front. So the CLI ends up, generating, I don't know, a couple of 100 lines of code that you don't have to write. So it is a massive time saver once it all starts building up. So it's kind of one of those features that sometimes you kind of don't use it because, I know how to write a component, but it does generate, it does save a lot of time. So if you're writing Angular, I think it should be like a necessity almost to use the CLI just out of a convenience point of view.
Yeah, definitely.
Modules is not as fancy as the component one because there's not really many assumptions they can make for you. So just another example of other things you can generate with it. So if you're generating a module, same deal as the component, you just type module instead of component and the name of your module, and it will generate that module inside that folder. Yes, so the CLI is quite diverse in what it can make. So you can see here there's it's everything that the CLI can generate for you. So this is just for the generate command. So there's probably some stuff in there, for example, that you've not seen before, but certainly stuff like component module are the main ones you'll use. I've started using it for pipes, enums, and guards. But as one of the interesting things is as you sort of add things such as materials is another big one. They've also got their own schematics. So it's not just components and guards and stuff that you can generate with the CLI, but material lets you generate tables. It will generate address forms. So considering the amount of time that the CLI can save you is more than worth checking out the documentation. Even if it's just for the generic Angular CLI generate command, like you can see here on the right. If you're using Material though, I recommend checking out theirs as well, because the table is quite a big time saver as well. So that will generate, your table markup, it'll generate your data source, it'll generate your paginator and everything like that. So it's just convenience, it's just time savers. It's not a necessity for working with Angular, but I would kind of almost say it was just for convenience sake.
Is that the sort of thing you can actually write your own custom ones as well, do you think?
Do you know, Robert, it's funny you say that. I am actually playing with that at the minute. We actually do have some in the eTech repository. I think Joe Percy was working on some. So it's just for some of the stuff, like when we generate a feature, it kind of follows a specific pattern. So for example, when I was talking earlier about how you do like the view, the list, the edit, I think JP's got a schematic in there which generates all of that for you. I don't think we really use it at the minute though, so it might be worth kind of checking out.
Maybe future talk.
Yeah, I mean, I do kind of plan on doing that.
So looking at components now, essentially components are just basic UI building blocks that we use to create stuff. I guess there's a lot of complexity over how we decide when to break the components up. I think Tom's going to show in a minute. You can sort of look at UI and go, oh, these are the components. Then there's more structure to that because they include components storing state, or they store things that manage state as well. And they have business logic in. So how you break them down is quite big. But essentially, the big thing with components is getting away from some of the old web dev where it was hard to reuse things without getting yourself into a big mess. And nice little segregation for, like, I can put my styles in here with them to style my page, and it's like nice little contained areas, which is, I think, definitely why nearly every popular like web framework now has components within it, and there's standards that are across the industry. So general components, basically they enable really nice reuse within your website. Also add localized styles. Definitely sort of used to have problems on bigger sites where styles would clash with each other because people didn't know that they already had things named the same. So really easy to understand abstraction. You can look at nearly every website and sort of just go, oh, okay, that should be a component. That's probably a component. Also, remember the sort of jQuery days of writing pages where people thought jQuery was great, but it's just like all you got was huge messes of index files. And then also we can share these components, even as far as sharing them between projects.
So we've got a screenshot here of the details page on PBQ. So at kind of first glance, I imagine you can kind of tell where the breaking points are on this page and where you can kind of split each individual component. Can you give me a clicky, Robert? So this is kind of the page that we're looking at the minute. It's the details page. So that in itself is kind of your master component, I guess you can call it. So that's kind of like our breaking point. And then we can break that up even further. So if you give another clicky, cool. We've kind of split it up into these 3 individual components. So you can kind of see they're kind of just all data display. So the only job these individual components have are just displaying data based on some data that's passed into it. And we can also kind of break this bottom right one up even more if you give another clicky. So each one of these contact cards can be its own component as well. So you're kind of just thinking, you've got an idea in your head, or you might have a design of how your feature is going to look. So the first thing you kind of want to do when designing this is how to break these up into components. Where the seams are in the application. So following on from that, we're talking smart and dumb. I talked about this a few times before in my last talk, if you call that. So there might be some overlap there. But in short, A smart component is kind of a component which has other responsibilities other than just like displaying data and being a view. So this could include like managing its own state. It could mean loading data, calculating some sort of business logic. That would kind of fall under the umbrella of a smart component. Whereas on the other side, you've got dumb components, which you can kind of summarize as its only job is to display some data based on some data input. So the advantage of these is they're predictable because there's no state to manage, there's no calculations really. So you can predict, as long as you always give it the same data, the output of the component is going to be the same. And then a follow-on from that, of course, is it's less buggy, it's more easily testable. There's no surprises. So if you think back to that PBQ slide, you could imagine, the smart component was the red outer box. You could imagine that having to fetch the data, the job data, and then passing it into those individual smaller blue boxes. And those blue boxes don't really have to worry about, fetching any data. They're just saying, give me a job and I will display it however you want me to. So by separating those components out, you've kind of ended up with these small, dumb, reusable components, because anything can pass it a job. It doesn't have to be this details page. So you can reuse that, job details summary page in a completely separate part of the application. Because it's dumb, all it needs to know is the job. Yeah, so that's pretty much dumb components. So as I said, when we tie our state and logic to the view, so if you've got that big red component, if you're loading the data, and then once you're loading the data, that component is also describing how to display the data, we're drastically reducing the reusability of that, because you've made the assumption that that component is going to be responsible for fetching the data as well as displaying it, if that makes sense. So for example, let's say that, you've got a component that fetches some data from an API and then displays it in a table. Just off the top of your head, you'd probably say, all right, well, on init, load that data, store it in local state. And then you've got a table on the markup of that component that just says, for every one of those items, display a row. So that data, that component isn't really reusable. So we can use what's called a container pattern, which is a very important thing for when you're defining sort of smart and dumb components, which can kind of give you the best of both worlds here. So, what if we wanted to display that list data somewhere else in the application? We would have tied fetching the data to the view if we did it in that sort of previously described way. So what we can do is what's called the container pattern. So we can create a container component, which is kind of like a parent component. And the only responsibility that has is to go fetch the data and store it in state. We'd then create another component, which would represent our dumb component, which would listen for that data. It'll just be an input property. And then that component would be responsible for displaying it. So you've got these two components instead. You've got your data fetcher component and you've got your display component. And so the advantage of that is you've separated your concerns already. So you've got your view component, which can be reused anywhere. It doesn't require you to go fetch the data. It just expects it to be passed in. So it's reusable, it's shareable, it's easier to test. It's less buggy again because you've sort of have your logic in isolation and you have your display in isolation. So it's kind of one of those pretty simple to do, but it makes a massive difference when you sort of designing your components. So it's definitely something I would recommend giving it a go if you haven't already, especially if you're sort of heavy on the tests. It makes it a lot easier.
Um, so change detection in Angular is basically how Angular decides when to redraw components. There's probably going to be a talk later. We'll go a lot more in depth on this. But from personally, I would say once you start getting more complicated projects, often little bugs are caused by how change detection works, and definitely from my point of view, like a lack of understanding of how that works. So it's definitely one to look at. It's really nice when you first start using it. It's very quick to pick up because when your input data changes, it redraws. It's all nice. It's definitely one worth having a look at how it works and getting an understanding of. Also, there is worth knowing there are different strategies available that can give different benefits and can be used for optimization as well. So it's worth just being aware of that and having a look. So modules are basically just a collection of similar elements. If you remember back to the slide where Tom showed everything that you can generate using Angular, there are a lot of different pieces. Now most of these can go within a module, and that just provides us a sort of a way to group commonly themed items together and then import and export them to different parts of the application. I guess the best way to think of it is like they're a small library. Me and Tom did have a discussion on this on like what they're similar to. And in some ways, it's like, I guess, a namespace, but they're just sort of a little bit different. Like more things can go inside them. You have to be more specific about inputs and outputs, imports and exports to them, which I guess a lot of is for performance reasons.
So this is an interesting topic. It's probably one of the first questions someone would ask when they're working with a module. You know, when should I make one? There is no set answer. If you ask, 100 different Angular devs, they'd probably all give you a different answer. But the things you kind of want to consider is the scale of your application. So for example, if you think about some of the Angular applications we've got, I don't know about other teams, but with the Lending UK ones at least, we have a shared module. I don't know if you've got the infamous share module in any of your applications as well. It gets big, like it kind of just gets treated as kind of like a dump because we didn't really think far into the future of how we're going to split our modules out. So some few pointers I think would be think about your domain, the different items in your domain. So for example, if you've got like a user entity, you've got a job entity, you've probably got some sort of admin entity, they would go neatly into their own modules. You can break that down even further if you really want to, if those are going to get big. So if your job module is going to get big, you might want to think about, a job list module, a job view module, a job shared module for sharing common elements. It really is kind of a how long is a piece of string? How big should I make a class? You can't really answer it. It depends on, the scale of your application. But if you generally think about a module, as Rob says, as a small collection of related components, related pipes, related directives, that's generally a good starting point. But yeah, there is no real right answer. I think as you sort of carry on working with modules, eventually you get to a point where you will realize, like, okay, this module is getting too big. I think that's a good way to go. You make quite a large-ish module, and then you kind of figure out when it's a good time to break it up. There is no number really, but if you find, you've got a large number of declarations in your module, if you've got an import section in your module that's like 100 lines, generally it's a good idea to start breaking that out. It's the same sort of deal as like if you're making like a C# class, really. If you end up with a boatload of methods, you generally get a good feel for, when it's time to start breaking some of those out into more specific classes. Same deal with this. You end up with more specific modules as your general modules get big.
So module definitions, I sort of have found it confusing going over these parts, but they all do make sense once you sort of start to get it. It's imports is basically things that I'm other modules that I'm going to use within my module. Exports, things that I expose to other modules that import from my module. Declarations is basically if you're adding a component, so that's sort of like a list of all of, well, not even just components, but basically all of the elements that are within this module. So that's things that belong to me. Providers, we're going to go on more detail later when we talk about services, but essentially it lets the dependency injection know where to insert instances of the class. It has to be provided somewhere. There are a few other options in that, but we'll touch on that in more detail later. Entry components, so me and Tom had to sort of Google this to find, I think we understand what they are, but like trying to work out a good explanation was difficult. But I think the best one we found was when you're dynamically creating a component. So I'm not creating it in the DOM or in my HTML, but I'm creating it through code. You need to register to the Angular module so that it knows that it's going to be created later, so that it can prepare for that. The best example of this is sort of dialogues, things like that are loaded up on click events and things.
Yeah, if you think about the mat dialog, generally you inject that mat dialog and you call open, and then you pass in a component, a component reference. That's kind of what you got to think about when it refers to like dynamically created components. It's like programmatically created components, but you can kind of just ignore most of that and just think if it's a dialog, put it in entry components. Don't worry about
it. Simple rule.
Yeah, it's kind of a good rule of thumb, really, especially when you're just starting out with Angular. 99% of the time, it's just going to be a dialog component, especially with the libraries we use. 99% of the time, it's just going to be a mat dialog.
I can't think of another case where I've used one.
Yeah, if you need to add anything else to the entry components, chances are you're good enough to know what an entry component is, so I won't worry about it. This is kind of how I personally think of a module. It might be a good rule of thumb for other people. So you can kind of think of a module as like a smallish API. So it's, as been mentioned before, it's a collection of sort of very similar components, very similar services, very similar pipes. And you're going to have some public and some private parts to that module. So for example, you could have like a dashboard component, which you want to export for everyone else to use. But that dashboard component could contain, your individual cards. It could contain some directives that are only relevant to that dashboard. So with a module, because of you've got that import and export structure, they kind of let you treat your components as private and public. So you can kind of just think of it as like a little API. And I find a little tip with this as well, which is very good for sort of sharing that module with everybody else and other members of your team. If you have an index.ts file at the root of that module, and that exports everything that is exported from the module, so your models, your services, and your exported components, it makes it very easy for other people to work with your module, because all you've got to do is kind of put an import statement at the root of that module, and you can use that barreling to basically see everything that's available from your module. It means people don't have to go dig into it and possibly import something that's not meant to be exported.
Cool. Yeah, as a note on that as well, I think we're going to do a talk on sort of basics of architecture, and we'll look at designing APIs for classes and stuff like that, and best practices, which will definitely hopefully be more detailed and helpful on this.
Just a quick note before you move on entry components are now deprecated. You don't need them in Angular 9. So
Is it from
obviously
9 then?
not worth thinking about it anymore.
That's good.
Make it more
The components were there to stop when it does tree shaking. If it's not referenced in a template, it used to shake it out. So you needed a reference. It didn't get rid of it.
So what have they done? Smarter tree shaking now or something?
It's
I don't know.
It's to do with
Which
how
a new compiler can probably pick it up in your code somewhere where old one couldn't. Or something.
I believe
yeah, it's still in there in 9, but in 10 it'll be removed.
Yeah, they're also working towards like it's to do with how each component sort of defines how to build itself. It has like a factory. I won't go into too much detail, but they've basically changed how a component defines itself with Angular, so you don't need that anymore. They're also looking at removing modules as well, which is an interesting one, but probably not in the scope of this. Cool. Okay. Yeah. So we'll just go over like a quick summary of what to really take away from this. The first one is obviously take advantage of the CLI. It helps with a lot of the pain of scaffolding, a lot of the Angular stuff, a lot of the Angular building blocks. On that note as well, there's a few language features if you haven't installed them on VS Code as well. Most of them are from John Papa. There's a few other Microsoft ones, I think. Not Microsoft, so someone else has done it. They're basically a requirement. Well, they're not a requirement, but they're going to make your life so much easier if you haven't got them already. If you just started developing on Angular, you really do have to get them. Have a look at some snippets as well, so that can also make your life easier as well.
So second thing, have a think about your component structure before writing the code. I say this to people all the time. It's like anything you build and write out a little bit on paper first. So you're going to do a lot better if you've thought about it and you've got an actual design rather than sort of extracting out as you go in some ways, because moving things around is a little bit sticky as well in Angular. But yeah, definitely put some thought into how you're going to break out those components.
You don't have to think about it too much because obviously it's something that you can come back in retrospect. You probably won't really know your breaking points of your application as well until it kind of gets a bit bigger. So don't fret on it too much. Just try and do your best. But I think with your kind of smart and dumb component pattern and your container pattern as well, it's something you can kind of think about straight away because it really does make your life easier when it comes to sharing components. The less you have sort of tied to your view, the easier life's going to be. So yeah, if you're designing a new component, it's just something to think about. Even if you don't think it's relevant to you, it might be worth giving it a go anyway, just to sort of see how it feels for you.
I think that all ties together as well. Is if you're spending like a little bit of time thinking about it beforehand, that's when you go, oh wait a minute, remember I've got to do my smart and dumb and actually think about how that's going to work.
Yeah, with the dumb components as well, your dumb components are generally small. So it kind of helps you to think about your breaking points of your application, and it does keep your components small, which obviously keeps them simpler and less buggy and easier to test. It's just more writing, of course, but hey ho.
Split your features and domain into modules. So this again is something we'll probably start touching on in some of the sort of low-level architecture stuff. Is basically when to split, but you want your splits to generally be on sort of your big business things, like have different high-level modules for each business area, and then within that you might also have like smaller little technical modules for things that aren't really related to the domain. Like if you've got a load of date pipes or something like that, they might go into a little date module. Or I think generally we do have a bit of a shared module, but as Tom says, they can get a bit big.
It's fine. Just don't kind of take advantage of them, or don't treat them as just like I don't know where this goes, I'm just going to put it in shared.
Yeah.
Like it is kind of app wide, domainless kind of thing. Cool. Yeah, finally, if you think of your module as these individual APIs, it does help to sort of encapsulate a lot of your components and items on a domain level as well. It also makes sure that you kind of if you're thinking of this public and private kind of thing, it does keep your components kind of very shareable. And if you take it into consideration as well, it's kind of difficult to design a component that's shareable before you even know how it's going to be shared. It's generally not a good idea to try and make it overshareable. You don't want to be making too many assumptions about your application when it doesn't even exist yet. But if you generally think about these as like individual APIs, you've probably written APIs before in other languages, but those sort of same concepts apply here. So it is sort of knowledge you can carry on into Angular. So it's just generally a good idea to have that mindset, I guess, when designing your modules.
Cool. Any questions? Okay, I will stop the record. Oh, is that a question?
No, I said we're clear.
Okay.
Got away with it.